In this section, we have absolute convergence, the ratio, and root test. Definition is series S of n convergence absolutely is absolutely convergent if the corresponding series of absolute values, sum of absolute value of S of n converges. Theorem 12, the absolute convergence test if sum of absolute value of S of n and from 1 to infinite converges, then what that means, sum of S of n and from 1 to infinite also converges. Theorem 13, the ratio test, let sum of S of n be any series and suppose that limit of absolute value of S of n plus 1 divided by S of n as n approaches infinite is equal to p. Then the series converges absolutely if p less than 1 and the series diverges if p greater than 1 or p is infinite. And the test is inconclusive if p equal to 1. Theorem 14, the root test, let sum of S of n be any series and suppose that limit of roots of absolute value of S of n as n approaches infinite equal to p. Then the series converges absolutely if p less than 1. The series converges if p greater than 1 or p is infinite. And the last one here that we have, the test is inclusive if p equal to 1. Example, use the root test to determine if the following series converges absolutely or diverges. So here we have series 11 divided by 10 times n plus 9 to the nth power, and n is from 1 to infinite. Let a sub n equal to 11 divided by 10 times n plus 9 to the n power. So finding nth root of absolute value of a sub n, and that is equal to a root of absolute value of 11 over 10 times n plus 9 to the n power. So this is equal to, on top numerator we have nth root of absolute value of 11, and denominator we have nth root of absolute value of 10n plus 9 to the n power, and this is equal to n root of 11 divided by 10n plus 9. So I eliminate this radical because here we have n, and that is power, and here index, that is n, so cancel that part. Now finding limit is n approaches infinite. So here on top we have n root of 11, and that is 11 power 1 over n. So if using infinite here instead of n, because here finding limit n approaches infinite. So having infinite here in denominator, we're going to have 11, 1 over infinite, and 1 over infinite is 0. So we're going to have 11 and power 0. So that will be equal to 1. So here we have 1 on top. And denominator we have 10 times n, and here n approaches infinite. So we have infinite in denominator. 1 over infinite is 0. So our limit is 0, and this is less than 1. So what that means, the series converges absolutely. Use any method to determine if the series converges or diverges. So here we have negative 3 to the n power divided by 10 to the n power. Let a sub n equal to negative 3 to the n power divided by 10 to the n power. So here on this board I'm using ratio test, which is limit of absolute value of a sub n plus 1 divided by a sub n n approaches infinite. So this is equal to limit of absolute value of on top for a sub n plus 1 we have negative 3 power is n plus 1 divided by 10 power is n plus 1. In denominator we have negative 3 to the nth power divided by 10 to the nth power. So first simplify. This is equal to limit of absolute value of what we have for a sub n plus 1 is negative 3 power n plus 1 divided by 10 power n plus 1, and then instead of division I use multiplication and use the reciprocal of what we had here in denominator. So multiply 10 to the n power divided by negative 3 to the n power, and this is equal to limit of absolute value of. So here simplify, we have this part divided by what we have here in denominator. So we're going to have negative 3 on top, and that's for 10 to the n power divided by 10 power n plus 1. We're going to have 10 in denominator. So here we have negative 3 in numerator, and denominator we have 10. So limit is equal to 3 over 10, and this number is less than 1. Since 3 over 10 is less than 1, the series negative 3 to the n power divided by 10 to the n power converges absolutely by the ratio test. Since the series converges absolutely by the absolute convergence test, it converges. Does the series defined below converge or diverge? When we have here for a sub 1 that is equal to 2, a sub n plus 1 is equal to 2 plus sine over n times a sub n. So using the ratio test, here we have limit of absolute value of a n plus 1 divided by a n, that is equal to limit. So for a sub n plus 1 we have 2 plus sine over n times a sub n divided by a sub n. So this is equal to limit. Here we can cancel this part, so a sub n divided by a sub n. So here we have 2 plus sine n divided by n. So sine theta is between negative 1, positive 1 inclusive. Based on that, what we have here on this part is 2 plus sine over n. So here we have sine, and we added 2. So we're going to add 2 on this part, and here on this part, on the right side. So we have 2 minus 1, and we have 2 plus sine. We have 2 plus 1 on right side, and then divide by n all of these. So here divided by n, we have 2 minus 1 over n, 2 plus sine theta over n, and 2 plus 1 over n. And then simplify, so we have absolute value of 1 over n less than equal to absolute value of 2 plus sine over n less than equal to absolute value of 3 over n, and this is for all n greater than 0. By sandwich theorem, limit of absolute value of 2 plus sine theta over n as n approaches infinite, that is between limit of absolute value of 1 over n and limit of absolute value of 3 over n as n approaches infinite. Now finding limit of 1 over n and limit of 3 over n as n approaches infinite. For both of these we have 0, so limit is equal to 0 for 1 over n and 3 over n. What that means, limit of absolute value of 2 plus sine over n as n approaches infinite. Here we have 0, and here we have 0, so on left and on right we have 0. What that means, what we had here on this part, limit of absolute value of 2 plus sine over n as n approaches infinite is equal to 0. So our answer is 0. This means that the given series converges absolutely by ratio test, so it converges. Does the series defined below converge or diverge? a sub 1 is equal to 1 over 2. A sub n plus 1 is equal to 1 plus natural log n divided by n plus 10 times a sub n. Using ratio test, here we have limit of absolute value of a sub n plus 1 divided by a sub n as n approaches infinite. This is equal to limit of absolute value of, for a sub n plus 1, we have 1 plus natural log n divided by n plus 10, and then multiplied by a sub n. And here denominator we have a sub n. We can simplify, so we can cancel this part. So simplify here, we have limit of absolute value of 1 plus natural log over n plus 10. And this is equal to limit of absolute value of 1 over what we have in denominator. So 1 over n plus 10, then plus natural log over what we have in denominator, n plus 10. Both terms inside the absolute value are positive. This means that this is equal to limit of 1 over n plus 10 plus natural log over n plus 10. So here on this part, I didn't use absolute value because these two terms are positive. So absolute value of these two terms is equal to what we have here on this part. And that is equal to, so limit of, I'm rewriting that part without using parentheses. So limit of this part, 1 over n plus 10, and then plus limit of second term, limit of natural log over n plus 10 as n approaches infinite. So this is equal to, we have 1 over infinite, that is 0, plus here again we have 0. So our answer is 0. So this means that the given series converges absolutely by ratio test, and so it converges. Note that using the root test here for this example is not possible because for this series we don't have an exponent or roots, so we're not able to use root test and simplify. So we have to use ratio test. Does the following series converge or diverge? So here on this part we have 7 to the n power times n factorial to the n power divided by n to the n power and then square. And this is from n from 1 to infinite. Let a sub n equal to 7 to the n power times n factorial to the n power divided by n to the n power. And here we have square, so our power and denominator is 2 times n. Now using root test, finding limit as n approaches infinite. So here we have n root of absolute value of a sub n. And this is equal to a limit of n root of absolute value of 7 to the n power times n factorial to the n power. Denominator we have n power n and then square. So simplify, so here limit of n root of 7 to the n power times n factorial to the n power. Denominator we have n to the n power square. So here on this part I don't have absolute value because what we had on top is always positive. So here we have absolute value of this one here inside absolute value, that is always positive. So rewriting that without using absolute value because it is positive. And now simplify. So on top numerator we have n root of 7 to the n power times n factorial to the n power, and denominator we have n root of n to the n power square. So here we can cancel radicals. So simplify. This is equal to limit and approaches infinite. We have 7 times n factorial on top. Yes, here we have same power. We can cancel that. So n We cancel that part. We don't have radicals, so it is 7. And that is same thing for this one. Power is same as what we have here for index. That means that we can cancel radicals, so we're gonna have n factorial. So it is 7 times n factorial on top and denominator. Here again, we have same power as index. That means we can cancel radical. What's left is n squared in denominator. Now find a limit of 7 times n factorial over n squared. As n approaches infinite. So I'm going to rewrite this part as the product of polynomials. So this is equal to limit 7 times. So instead of n factorial, I'm going to write n times n minus 1 times n minus 2 factorial divided by what we have in denominator n squared. So this is equal to limit. So simplify this part, n divided by n. So that part cancels. We're gonna have n in denominator. So we have n over n squared, and divide each one by n. We're gonna have 7 times n minus 1 times n minus 2 factorial divided by n. Recall that what we have for n factorial, for example, let's have n equal to 3. Finding n factorial, in this case 3 factorial, that is equal to, starting with the number that is given here on this part, it is 3, then multiply 3 minus 1, 2, 2 minus 1, 1. So the answer is 6. So this is how we can find factorial. Now finding limit. So first I simplify. So this is equal to limit as n approaches infinite. We have 7 times n minus 2 factorial, and then we have n minus 1 over n. So n divided by n is 1 minus 1 over n. So as n approaches infinite, this part approaches 0 because we have 1 over infinite, that is 0. And for this part, we're going to have 1 minus 0. So it is a 1. And here on this part, we have n. So n approaches infinite, we're going to have 7 times infinite. So this is equal to infinite. So limit is equal to infinite. That means that the given series diverges by the root test.